Alright, part 2. Accidentally stopped recording last time, so we had to make a part 2. Same thing, we're still solving systems of linear equations. In my next example, I have y equals x squared. So we know that's a parabola, that's the parent function. Parabola. And we have y equals 8 minus x squared. Y is not squared, x is squared. And we know that is also a parabola. It's quadratic. They're both quadratics, they're both parabolas. 8 minus x squared, yeah. Now, in this case, both equations already have an isolated variable. Again, it doesn't matter if it's x or if it's y that's isolated, as long as the same variable is isolated on both of them. I like my y's to be isolated, but if they gave it to me where x was the one that was isolated in both of them, that's fine. I wouldn't change it. But if I had to get one isolated, I just choose y. Since they both have the y isolated, and I want to know where these two equations equal each other, I'm going to take what y is equal to in each equation and set them equal to each other. So I'm trying to figure out what x is. What do y'all think I should do? What should I do? Add 8? Oh, add x squared? Yeah. That's what I would do. Since you only have a quadratic term and a constant, I would not worry about getting everything set equal to 0 because I could just solve for x easily. So what is x squared plus x squared? 2x squared equals 8. Negative x squared, positive x squared makes 0. Now what? Divide by 2. So we have x squared equals 4. Then what? Square root. And I'm going to take the positive and negative square root of 4. So x equals positive negative 2. That one was a lot easier than the last one. But if I found my answer, no, I only found that I'm going to have two solutions. One that has an x value of positive 2 and one that has an x value of negative 2. Okay? So I have to find the y values for both of those. So I know I'm going to have two solutions. One is x equals positive 2. The other is x equals negative 2. So does it matter which equation that I use to figure out the y value of those? Doesn't matter. They're going to be the same ordered pair for each equation. So I'm just going to choose the top one because it's got less going on. So y equals x squared. And when x equals positive 2, and y equals positive 4. So 2 comma 4 is one of my solutions. And when x equals negative 2, y is still positive 4. So that's my other solution. Right on. Let's do another one. This next one's going to take me a little more room, so I'm going to go ahead and start a new sheet. You don't have to, but that's what I'm going to do. So this is my third example, right?
Take up like the first one did, or what?
This next one will take up a lot of room. So let us solve the system. Y equals negative x minus 3. What kind of function is that? Yep, it's a linear function, right? X's exponent is 1. And x squared plus y squared equals 17. What's that going to make if we graph it?
A big old curve.
We only talked about it today. Circle. Circle. X squared, x is being squared and y is being squared. Circle. Okay, so we've got a line, so it's linear, and we have a circle. So we could have two solutions, right? We may only have one solution if the line is just tangent to the circle. It just depends. We're going to have to work it out and see. But could we have any more than two solutions? No, the line's not going to turn around and come back, right? All right. So in my linear function, y is already isolated. So in the circle, the function of the circle, I would also isolate the y since that'll take me less work, okay? So I'm going to rewrite my circle function. I want to isolate the y. So what will I do first?
Try x squared.
You know it. So I have y squared equals negative x squared plus 17. Now what am I going to do? Square root both sides. Square root of y squared is y. Can I take the square root of negative x squared plus 17? No. So I'm just going to leave it as square root negative x squared plus 17. So now in both of my equations, the y is isolated. So I'm going to take what the y is equal to in each equation and set them equal to each other. And I need to solve for x. I've got an x on the left side and an x on the right side. What do y'all think I should do first?
Square.
Square it, right? Let's get rid of that radical sign. So the inverse of square rooting something is to square it. So on the left side, please do not square those individually. They go together. Didn't that used to have 3 tones?
No.
Never?
Yeah, it used to.
I feel like I'm not.
Metals though.
I feel like that used to be 3 tones. And on the right side, when I square the square root, the only thing it does is get rid of the radical sign. It does not change anything under the radical. Alright, so on the left side, I'm going to distribute those two binomials, or FOIL. Negative x times negative x is
Negative squared.
positive x squared. Negative times negative positive, right? Negative x times negative 3?
Negative 3x.
Positive.
Positive 3x. Negative 3 times negative x.
Positive 3x.
Positive 3x. Negative 3 times negative 3?
9.
Positive 9 equals negative x squared plus 17. Okay, on the left side I can combine like terms and have x squared plus 6x plus 9 equals negative x squared plus 17. I can see I've got quadratics and linear and constant terms. So I can't just solve for x. I'm going to need to get everything on one side or the other and set it equal to 0.
Can you use this quadratic formula?
Not here. I can once I get it set equal to 0. But I can't use the quadratic formula or factoring or anything until it's set equal to 0.
Okay, just add the x then.
Bless you.
Thank you. Yeah, I'll add x squared to both sides. And I'll subtract 17 from both sides. So x squared plus x squared is
2x.
2x squared. The plus 6x, I have no like terms to combine it with. And then positive 9 minus 17, negative negative 8. Now I'm thinking I might be able to factor this.
The common factor.
There is a greatest common factor. Now if I use the quadratic formula, do I take out the GCF if there is one?
Yes.
Right. Well, if I'm doing the quadratic formula, I don't take out the greatest common factor. I only take out the greatest common factor if I'm factoring. So since I'm going to try to factor and there is a GCF, I'm going to factor it out. What is the GCF? 2. And remember, if your leading term is negative, you want to factor out a negative also. This one isn't, so we won't. So I'll factor a greatest common factor of 2 out of every term. So what am I left with? You know it. Now, since I'm going to use the T-chart to factor, when I pick A, B, and C, remember, now I'm only factoring what's inside the parentheses, not my original. So when you pick A, B, and C, you pick the A, B, and C from what's inside the parentheses. So what is A?
A equals
1. What is B?
B equals 3.
And what is C?
4. Negative 4.
Am I going to have to divide and slide on this?
Yes.
No. I'm not looking at my original. I'm looking at what's inside the parentheses where your coefficient of your quadratic is 1, right? Alright, so make your little T-chart short and stout. You need two numbers that multiply together to get A times C, which is negative 4, and add together to get B, which is positive 3.
Negative 4 times 1. Negative 4 times
Positive 4 times negative 1 is negative 4, and 4 plus negative 1 is positive 3, right? So we have 2 times x plus 4 and x minus 1. How many solutions am I going to have? 2, but I see 3 factors. Exactly. Because when I said 2 equal to 0, 2 does not have a variable, and 2 does not equal 0, right? So while 2 is a factor, it does not help me with my solutions. If I set x plus 4 equal to 0, and I solve for x, I get a solution of negative 4. So there's one solution. It's not an ordered pair. It's just the value for x. And when I set x minus 1 equal to 0, x equals 1. So how many times is this line going to intersect this circle? Twice. Do we know the ordered pairs in which this line and circle will intersect? No. We know the x values are the ordered pairs, but we don't know the y values. So I got to find the y. Does it matter if I choose the linear function or the function of a circle? No. I'm going to choose linear because nothing's squared and it just seems easier. So I'm going to have to find when x is negative 4 and when x is 1, and I'm using the linear function of y equals negative x minus 3. Be careful because you're going to have some double negatives, and you don't want to do all that work correctly and mess up here. Anybody have questions on that one? Where did I get it? Like right here? It came from my problem. So once you find your value of x, pick either one of the equations that were given to us and plug it in. Yeah, I could have plugged it into the function of the circle, just as well as I could have plugged it into the linear. It doesn't matter. You're going to get the same answer for either. I just usually pick whichever one's going to, seems like it's going to be the easiest to simplify. Coolio? All right, let's get one more done, and we will call it a day. In this class, at least. We'll have to call it a day because the bell will ring. Oh, we do. It's 12:02. Example 4. I will be looking for all 4 examples on your notes to get full credit. You choose not to? Hey, it's your grade. Solve the system. Y equals 1/2 x minus 5. What kind of function is that?
That is a depression
Linear. And y equals x squared plus 2x minus 15. What kind of function is that? Quadratic. So basically, we're going to find where a line and a parabola intersect, right? Probably looking for 2 solutions. Unless the line was tangent to the parabola, then we would only have 1 solution. Or say the line was horizontal and it was under the parabola, like, you know, like a directrix or something, then they wouldn't cross, we wouldn't have a solution. But probably we're looking for 2 solutions.
They wouldn't do that, right?
Let's say we did.
They would, yeah, why not?
We did.
So you have to do all that work and just be like.
It could happen. Okay, so in both of these equations, thank goodness the y is already isolated, so at least we don't have to isolate anything, right? We can go ahead and set the equal to each other. So I'll set 1/2 x minus 5 equal to x squared plus 2x minus 15.
We just have to factor x, the quadratic, right?
We can't factor it until it's set equal to 0.
Oh.
Okay? But once it is, then we will. Or we'll try to.
So we add the 1/2 x to the 2.
I could add the 1/2 x to the other side, but what I would probably do is I personally would prefer to clear the fraction. I don't want to deal with fractions and quadratics and factoring and all that stuff. So if I want to clear the fraction, I could multiply every term by what?
0.5.
2.
1.
It's the denominator of the fraction. Okay? Because what's 1/2 of 2? If you have $2 and I take half your money, 1, right? So that's going to be 1x, which is just x. But I can't just multiply one term by 2. I have to multiply every term by the same thing. Otherwise, I change the meaning of the problem. So, like I said, 2 times 1/2 x, which means half of 2, is 1x or just x. 2 times negative 5 is negative 10. 2 times x squared is 2x squared. 2 times positive 2x is positive 4x. And 2 times negative 15 is negative 30. So it's an extra step, but at least I don't have to deal with fractions now, right? So now I'll get it set equal to 0. I'll move that x over. And I'll move that 10 over to the right side. What's x minus x? 0. It's negative 10 plus 10.
X minus that 4x?
No, over here. So equals 2x squared. There's no like terms, so I'll just bring it down. Positive 4x minus 1x is positive 3x. Negative 30 plus 10 is negative 20. Of course, I want to factor this if I can. It's a quadratic. That's our easiest method. Is there a GCF?
No.
And no. So I'm going to need, we know A is 2, B is 3, C is negative 20. 2 numbers that multiply together to get A times C, which is negative 40, and add to get B, which is positive 3. Now, is everything factorable?
Oh, you can do 5 and 8, something like 5 and
Such as,
8. You can do, positive 8 times negative 5.
positive 8 times a negative 5 is negative 40. 8 plus negative 5 is positive 3. Now, when I did this on my paper, I totally wasn't thinking about 8 and 5. Why? I don't know. I probably just saw at 40 and 3 and just said, I'm just going to go straight to the quadratic formula. So I did quadratic formula. Does that mean if we factor here and I use the quadratic in my notes that one of us is right and one of us is wrong?
No.
No. Are we going to get different answers?
No.
No. It's just a different method, right? Factoring does not always work. Quadratic formula always works. Okay, so we have x plus 8 and x minus 5.
You have to divide each other.
I have to divide and slide. Why do I have to divide and slide? Because a is a number other than 1, right? So the numbers that we found in the t-chart, you're going to either divide if you can. If not, you're going to slide. Remember, if it's a slide, you have to reduce before you slide. So x plus 8 halves, am I going to divide or am I going to slide?
Divide.
I'm going to divide because it divides evenly, right? So it's x plus 4. 5 halves, divide or slide? Slide, because 5 doesn't divide by 2
But you
evenly.
can reduce it.
Can I reduce it? No, if I could, I would have to before I slide, but I can't. So I can go ahead and slide this 2 up in front of the x, right? So that will become 2x minus 5. Now, are those my factors?
No. I mean, they're your factors.
They're my factors, but have I solved yet? No, but I factored completely. Now I gotta solve. So to solve, we know we set each factor equal to 0. And solve for the variable. I didn't mean to put those parentheses. Better white them out. Y'all don't have to wait for me for this. So if I was just solving the quadratic, I've solved the quadratic, but I needed to solve the system. I needed to find the ordered pairs where the parabola and the line intersected. Have I found those ordered pairs?
No.
No. Right, I got to plug it into either original equation, it doesn't matter which one, so I can find when x is negative 4, what is y? When x is 2.5, what is y? I'm going to use the linear equation, you use whatever you want to. It's a free world, country. So I'm going to find when x is negative 4 first. What's half of negative 4? Negative 2. We need a calculator for that. make sure your name's at the top of your paper. You should have 4 examples there. And I will collect those, pass them up.